Welcome back. This is part 3 of Ratios Lesson 1. If you haven't watched part 1 and 2, please do so before participating in this lesson. Before we get started, please be sure to have paper and pencil to follow along with me, and remember to scan your work to me when it's completed. I am also attaching the following worksheet that goes along with the video, which can be printed or you can split the screen and do the worksheet on the computer like so. So you could, come on. Doesn't want to load apparently. Oh, there it is. So this is what the worksheet looks like. You could pull it out like this. Okay, make it a little bit smaller, and then make it so that way you can see both screens at once. Okay, so I'm gonna make, this one smaller as well, so that way I can look at the worksheet. Oh gosh, this is not cooperating with me. Okay, if I can look at the worksheet and the video at the same time. And I just want to make this still a little bit smaller. Okay, so you see how I can see the video, what I'm doing, and the worksheet. This is another great way. So today you're going to watch 2 videos as an introduction to tape diagrams, and then we're going to answer the last question together. I'm going to go ahead and play the video for you.
Hello there, you little mathematicians. Today we have a very short video on ratios and tape diagrams. So tape diagrams are a way of just visualizing a relationship that is expressed through a ratio. We're going to look at this scenario here. Susan has a bag full of marbles. The ratio of red to blue marbles is 6 to 5. Okay, now before we get into the tape diagrams, I want you to just ponder a quick question. Do we know how many marbles are in the bag? What do you think?
If you're doing
The answer is
the worksheet on the computer, you could just simply bold whatever you think the answer is. Oh, gosh.
the answer is no. So we know she has a bag full of marbles and that the ratio of red to blue is 6 to 5. But that just means for every 6 red marbles, there are 5 blue marbles. We don't know exactly how many are in there. It could be 11. It could just be 6 plus 5. But we're not sure if that's true. Okay. Now we want to look at these tape diagrams. These are tape diagrams of ratios. There are 2 of them here. And now I want you to just pause for a moment and think to yourself, if you can tell which of these 2, here's 1, here's 2, properly illustrates the ratio that's being expressed in this statement here. Ratio of red to blue marbles is 6 to 5. Well, in this tape diagram here, we've got 1, 2, 3, 4, 5 red, and 1, 2, 3, 4, 5, 6 blue. Is that correct? It's not, because what the statement says is that red to blue is 6 to 5. So this is the correct one down here, because we have 1, 2, 3, 4, 5, 6 red, 1, 2, 3, 4, 5 blue. So today we're just getting a quick introduction into what tape diagrams are, what they look like, how they are just taking this ratio here and expressing it visually, 6 red, 5 blue. They're a powerful tool that we're going to use to solve some harder problems. So this is just a quick, short video to let you see what they are. See you in class tomorrow. Thanks.
Okay, so now I'm going to play for you the second part of the video, which would be these sets of questions right here.
Hello again, you little mathematicians. Today we're going to take the tape diagrams that you learned about in the last video and use them to help us solve some more complex ratio problems. Just to remind ourselves, here's the scenario from last time. Susan has a bag full of marbles. The ratio of red to blue marbles is 6 to 5. Here's a tape diagram representing that situation. We've got 1, 2, 3, 4, 5, 6 red bits of tape put together and 1, 2, 3, 4, 5 bits of blue tape. So this shows the ratio is 6 to 5, the ratio of red to blue, 6 red to 5 blue. Now we're going to complicate this situation a little bit. So we're still talking about the same bag of marbles, ratio of red to blue is still 6 to 5, but we're wondering if there are 54 red marbles, how many blue marbles are there? All right, the ratio is 6 to 5. For every 6 red, there are 5 blue. If there are 54 red marbles, how many blue marbles are there? At this point, I want you to pause the video and try to solve this problem on your own. If it takes you a minute or two, that's fine. Struggle with it for a bit. See what you can come up with. All right.
Okay, so you should be struggling with this problem just a little bit right now. I'm going to resume the video in a minute. Okay, I'm going to continue the video now. I hope you had some time to struggle with that a little bit.
Let's see if your answer matches mine. So I want to use this tape diagram to help us solve the problem. Remember, this represents our red marbles, this represents our blue marbles. So we know that we have a total of 54 red marbles. So let's just draw that in here. We know that total, we've got 54 red marbles, right? And so now if all 6 of these little pieces of tape add up to 54 red marbles, how much is each of them? Well, 54 divided by 6 is 9. So each one of these little pieces of tape is representing 9 red marbles. Well, if each piece of tape represents 9 marbles, that's going to be the same down here. And so now you can see our ratio is still 6 to 5, 6 red to 5 blue. Now we're looking, we can see, oh, it's 6 groups of 9 red marbles to 5 groups of blue marbles. Of 9 blue marbles, excuse me. And so how many total blue marbles do we have? Well, 9 times 5, that will give us 45 total blue marbles. So the tape diagrams give us this visual way of looking at our ratio and solving a problem that we otherwise might not have been able to see so visually. Let's try another one.
Okay, so now I'm going to go ahead and I would like for you to continue doing this problem with me right here, scenario 2. So, okay, so here we have, and I have what you have in your paper, I just made mine color. On Mr. Rag's BART train, the ratio of male to female passengers is 4 to 3. There are a total of 28 passengers. How many of them are female? So 4 represents the males because it was said first. So what I like to do is I like to label. So I'm going to put M. Okay. Oops. Not working at the moment. Let's see. Let's try this. Nope. This is so typical for me, huh, guys? All right, here we go. Let's try this. Here we go. So M for males on this row, and then females are 3. So I'm going to put F right here. All right, so we have the males and we have the females. So now it says there are a total of 28 passengers. So I know that all of this right here is equal to 28. Okay. They're wondering how many of them are female. So what I have to do first is I have to figure out how much each of these parts is equal to. So if this all equals 28, what I'm going to do is I'm going to count the number of boxes I have all together. I have 1, 2, 3, 4, 5, 6, 7. So I have 7 boxes altogether. I'm going to distribute this 28 evenly between each of these boxes. So if I'm distributing a number evenly between boxes, what operation am I doing? Think for a moment. I'm doing division. So there's 7 boxes altogether. So 7 as my divisor and 28. Now, if we know our multiplication facts, or if you can think back to all those reference sheets we made all year long, you're going to know or remember that 7 goes into 28 4 times. So that means that each of these boxes here are equal to 4. So I would like you to do this with me. Make sure you're filling this out with me as I go. So this box has 4. This one has 4. This one. Oops, that looks like a U, not a 4. There we go. This one has 4, 4, and 4. Okay, so now I can answer my question. Now that I know what each box is equal to, I can answer the question of how many females there are. So I have 3 boxes and 4 of them are each. So that would be 3 times 4. What's 3 times 4? Three times 4 is 12. So there's 12 female passengers. Let's find out how many males there are, just to extend the question a bit here. So this would be 4 times 4. What's 4 times 4? 4 times 4 is 16. Nice. So to answer our question, there are 12 female passengers. In the next video, we're going to try some more problems together. Until then, I'll talk to you guys later. Bye.